Hi guys. I think this is working now. Okay, so these are answers to your review questions from, oh man, this thing got messed up, sorry. To your review questions for the test today. So watch these before you take the test, obviously. I hope you guys are doing well. I miss you all very much. And I hope, I don't know. I hope this goes well today and that it's not too much. It is a shorter test than normal. I want this thing to go away. All right, so hopefully it'll be okay. So the only questions that I got were on 10 and 11 on the review. I believe Chloe asked about 7C and then retracted it. So we are just doing 10 and 11. So it'll be a quick video, I guess. So number 10, pick like the worst pen possible. Use this. So number 10 says the diagram. Let me pull up my original solution so that I can see what you guys saw. Okay, so number 10, it says the diagram shows the graph of the function g of x. Okay, so it has this funky like map to notation that I think we've seen before. It's g maps x's to x sine x and then it gives the domain negative 0.5 to 3.5. Now, so this is the domain. And this really just means g of x is equal to x sine x. Okay. Oops, that's not what I meant to do. How come? Anyways. Okay, here we go. Let me get the white out. I meant to put little quotes around this side. There's a police car outside. Okay, so that's all that means. I don't know if that's like the issue. I don't think it was. Then it says the graph intersects the x-axis at a point A with coordinates a comma 0, and B is the maximum point on the this part of the graph. Okay, and it gives you the little picture. I think you can see it in the little corner of my page. Okay, so then it said find the value of A. So A is a 0 value, so I need to set g of x equal to 0. Okay, so we're going to have x sine x equals 0. So there are two ways that you can get the product of x and sine x to be 0. The first way is when x is 0. That way is already shown on here, and we know that that's not A because A is non-zero, okay? And the other way is to take sine x and set that equal to 0. So we know that sine x is 0 at 0 on the unit circle, but that repeats this solution. The next place that sine is 0, so we're asking sine of what equals 0 is going to be at pi. So pi must be x, okay? So sine of pi is 0, okay? So that means that our x must be pi. I probably should have put those in a different order. Okay, so let me see if that matches what I did. Yep. So this means that A equals pi. Okay, so that's part A. Then I guess I should write that. Part B, and then there were two parts. This pen is also dying. Whew. Okay, part B1, it says find g prime of x. So we're gonna have to use the product rule for this. So we do first times the derivative of the second. The derivative of sine is cosine plus the second thing, which is sine x, times the derivative of the first, which is 1. Okay, so our final answer is just x cosine x plus sine x. And then in part, oh, why did I do that? I wrote part 2, but this is just part 1. Okay, now part 2 is right here. Part 2 says show that the maximum point B, at the maximum point B, x satisfies that equation. So we would need to find B. In order to find B, we should find the maximum. And maximums can be found by setting the derivative equal to 0. So I'm going to set 0 equal to x cosine x plus sine x. Now, it just says show, well, okay, so let's try to solve this. So what I would do, what I would do is divide everything by cosine first. So divide by cosine of x on both sides. Now on the left, 0 over cosine x is just 0. The cosine x's will cancel out right here. They'll turn into a 1. So this is just 1x or x. And then sine over cosine is tangent. Okay. And so this is kind of all we need to find part 2. Let's see. Yeah, that's what we did. Okay, that's all we need for part 2. We don't really need a actual value. We're just showing that because this equation occurs at our maximum and x has to satisfy this equation, we know that it also satisfies this equation, which is what we had in part B2. Okay, so that's all they wanted for part B2, was just to show that when you set up to find the maximum, you end up getting the same equation. Okay, hopefully that makes sense to you. Now in part C, it says show that the second derivative is that. So part C will come down here. So I want to take this and I'm going to take the derivative again. So I'm going to need the product rule right here. So first, x times the derivative of cosine is negative sine plus the second thing, which is cosine, times the derivative of the first, which is just 1, and then plus the derivative of this thing, the derivative of sine is cosine. So now this 1 is just going to disappear. It's just the coefficient of cosine x. So this means that I have 2 cosine x's. So I'm going to have negative x sine x plus 2 cosine x. And that's all you needed for number 10. Okay, so probably the biggest things were this weird notation, showing this part in part 2 right here, maybe this. Hopefully this was okay. All right, let's move on to number 11. So number 11 says a right-angled triangle has a hypotenuse. So I'm going to draw a right-angled triangle. A right triangle has a hypotenuse of 15 centimeters. So the hypotenuse is always going to be across from the right angle because 90 degrees is going to be the biggest angle because the rest of the